This is AP Precalculus review for the final exam, known as our three-peat activities. We are on worksheet L. In number 1, we are asked to find what does G do to F in terms of this function. I'm noticing that the first two options are talking about factors of 3 versus factors of 1/3, clearly identifying this 3. The first thing that we need to know there is that this is always going to be a horizontal number on the inside of the parentheses. These all correctly say horizontal. Well, that doesn't help us. The other thing to know is that whenever we're on the inside of the parentheses, we always do the opposite. If I have any multiplication, it really means division. If I have any addition, it really means subtraction. Everything on the inside of the parentheses is an opposite. So the fact that these are saying factor of 3 means that they're incorrect. We should be instead doing the reciprocal of that, doing 1/3. So these two are correct. A and B are limited. And then next we have this 1/2 out here, vertical direction. Everything on the outside of the parentheses is the vertical direction. If we are adding or subtracting, we are translating. If we are multiplying or dividing, that is going to be dilating. Because we are on the outside, we are also doing the typical direction. If I have a 1/2 is what we should get, and the correct answer here is D. In number 2, we have a graph with a series of points on it. This is clearly a log function. There it is. It does not tell me what base I have for my log. It just says that the base is obviously not 1, because then it would just be a flat line. It would be very boring. And we also have an exponential function with that same base b right there. Okay, well, the first thing that I notice is that logs and exponentials are opposites of one another. They are inverses, really, of one another. Opposites really just means multiplied by -1. They are inverses of one another. They undo each other, or you can say that their x and y coordinates have been switched. So, and that second definition is really the one that we want to look at. So what I'm supposed to do is I'm trying to find points that are on the graph of k, which we don't know what it is, but we know it's the inverse of this function that's graphed up here. So one of the things we know about inverses is that you change the x and the y values and you switch them. So for example, if I look at this point right here and I say, well, that I would go 1 to the right and 0 up, because 1, 0 is on the graph of h, on the graph of k, I should have 0, 1 and switch those values. So I'm looking for 0, 1. Okay, those aren't there. I don't think they're going to do any sort of weird fraction, because that's maybe a half to the right and then a half down. Maybe they don't have any halves. Okay, so that's not going to be there. They must be talking about these 2 points then. So let's go ahead and identify these. On the graph of h, I'm going 4 to the right and 1 up. And on the graph of h, this is going 16 to the right and 2 up. So we just flip those, and this should be 1, 4. Oh, well, 1, 4. And this one should be 2, 16. 2, 16. The correct answer, therefore, is C. All right, in number 13, we have a terminal ray that is shared. Terminal rate that is shared just means the same thing, right? So I have 3 pi over 4. Again, if you don't know where 3 pi over 4, you need to study where your location of radians are. But on a unit circle, 3 pi over 4 is right in the middle in that second quadrant. And we are looking for one of these other points that shares that exact point on this unit circle. Technically, the ray is a line that has a beginning but no end, and it goes on and on forever. But if it intersects the unit circle, I'm just going to put that point of that intersection. So where is that spot? Well, -3 pi over 4 is going negative direction to this point. So I'll label this one. This point right here is -3 pi over 4, which does not share a terminal ray. That one is eliminated. What about -7 pi over 4? -7 pi over 4 goes all the way to right there. There's -7 pi over 4, -7 pi over 4, which is obviously not the same point. Therefore, B is eliminated. What about 5 pi over 4? Well, 5 pi over 4 is going the positive direction, or counterclockwise. 5 pi over 4 goes to right here. So this one is also 5 pi over 4, which is still not where we're looking for. This, again, we're looking for this 3 pi over 4, and so far nothing has matched it. Let's cross you off with pen. What about, it must be by process of elimination. It must be D, but let's talk about why. 11 pi over 4 means we are going, 11 pi over 4 is not a standard position between 0 and pi. They must have added a whole unit of pi, and I think that's what they did, because I think this is the same thing as 3 pi over 4 plus 2 pi. Because remember, 2 pi doesn't have the same denominator, so I can multiply the numerator and denominator by 4 and 4 to get that common denominator 4, and that's going to turn into an 8 pi over 4. So if I add that with my 3 pi over 4, let's go ahead and rewrite that again, plus 3 pi over 4. I can now add my fractions, and you still have divided by 4, and 8 plus 3 is 11, so I have a total of 11 pi. And indeed, 11 pi over 4 is the same as 3 pi over 4, but we rotated an extra 2 pi radian. So this is 3 pi over 4, and then we went all the way back around, and we got to 11 pi over 4. That shares a terminal ray. All right, that concludes 3-Peat L's worksheet for AP Precalculus. Thank you for watching.